Boston Dynamics founder Mark Raber probably has one of the most famous pet pooches on the planet, Spot the RoboDog. Spot has been busy since the lockdown, helping doctors remotely communicate with COVID patients in Boston, enforcing social distancing in Singapore, and herding sheep in New Zealand. He is truly a canine for our corona times.
Hi, I'm Mark Raber. I'm from Boston Dynamics. I'm really glad to be with you all today. I'm going to talk about one of the robots we're developing, the Spot robot. And really, I'm going to talk about the journey we're on. It's a journey that's involved lots of R&D in the past, some really exciting activity that's going on today, and some ideas for where we're going to go in the future with it. But first, some background. When I think of artificial intelligence, I think of it as having two kinds. The kind that's in our heads that I like to call scholarly intelligence. And that's used to do things like solve problems at work or at home, to make plans. Imagine you're going to go on a trip and you've got to make sure that you get to the airport in time, so you think about all the steps that you need to do and how much time you have to allow for each one. And scholarly intelligence even lets you sit in a lecture like this and learn about a new topic, one that you don't know that much about, and you have to interpret what I'm saying and fit it in with the context of your lives and other things you know. That's really a very interesting kind of intelligence. But there's another kind of intelligence, athletic intelligence. And that's the intelligence that is knowledge about how our bodies and how they work. Things that let me walk upright and balance on my feet, run and climb, use my body efficiently, so that I have more endurance or more strength. And it also lets me do real-time perception of the world around me, so I can interact with obstacles and adversaries and maneuver with respect to them in order to accomplish my goals. You know, most of us aren't athletes, but we all have a great deal of athletic intelligence. And Boston Dynamics focuses on giving our robots athletic artificial intelligence, and we're also working on combining it with scholarly intelligence that's developed by others. So let me show you some examples of athletic intelligence as it exists in the natural world. Here's a mountain goat using his perception to see the terrain, balance, and here's one of the most amazing examples of athletics at work in an animal, the cheetah, the fastest-legged animal on Earth. And here, even human beings have great amounts of athletic capability and athletic intelligence. It's really amazing, the combination of mobility, dexterity, perception that they use to do this. Let me show you a little bit of the work that we've done on athletic artificial intelligence in the terms of our robots and how that has played out over the last 10 years or so. I think many of you must be familiar with Big Dog. This is a robot that operates on terrain, balancing itself, using onboard power and onboard computing, and in particular has algorithms for balance and control that let it tolerate disturbances like this, react to the terrain, and deal with a variety of situations. Here's a case where we accidentally ran it on some ice. Its reflexes kicked in and kept it on its feet even though it didn't have any traction. Here's another robot we developed which is designed to carry a heavy load out in the field. It's designed to carry 400 pounds and travel 20 miles. And this robot doesn't have to be driven. It uses a vision system to follow a human leader. And that's what it's doing there. And of course in Boston, where we have snow, the value of having legs really shows itself because you can go on terrain that wheeled and tracked vehicles can't go on. This is the fastest legged robot that's ever been built, a cheetah robot that goes about 20 miles an hour, not as fast as the real cheetah, but fast and very challenging. So let's talk about Spot. Spot is a small four-legged robot that we've designed to be a platform. It's a platform just like your cell phone is a platform, which means that we've developed a certain set of functionality, but other people can add hardware and software to the robot to adapt it for a wide variety of purposes. Here you can see some of the add-on hardware that we've developed. There's a robot arm, there's a LiDAR, there's a 360 set of cameras that provide images in every direction, there's an extra computer, and there's several others that aren't shown here. But our real goal is to make it so that you can design add-ons that you put on yourself. In addition to mechanical add-ons, Spot's designed to accept software, so it has an API that's open, and we expect third parties to develop applications that run on top of Spot. We hope that Spot is going to be the mobility platform and that others can develop scholarly AI that does things like figure out the plan for a problem and then has the robot execute on that. This is the point in the presentation where usually I bring a robot on stage to do a live demo. But today we've gone on a little field trip and we're going to do the demo out here. Danielle and Keith are helping with the demo. Danielle's got a tablet that communicates with the robot, and she gives high-level guidance to the robot. And here Spot's doing a slow walking gait, using one leg at a time. And it's being coordinated and balanced by its onboard computers. Now it's switched into a trotting gait where it uses diagonal legs together. And you notice it made that transition seamlessly. All Daniela had to do was press a button, and it did everything. And now it's running with a different kind of jogging gait. And the whole time, the onboard computers, the IMU, the leg sensors are being used in order to keep the robot balanced, control its speed, the direction of travel. One of the cool things about legged robots is they're omnidirectional. They can go fore and aft, as you've seen. They can go sideways. They can turn in place. And they have a lot of control over the orientation of their bodies. So Danielle is going to pose the body, nose up and nose down. It can twist and roll, and even in yaw. And this is really important in a mobile manipulation robot because it adds to the motion of the arm. You notice we have an arm on this robot, and the arm will work in conjunction with the motions of the body. And this means that the reach of the arm isn't limited by the length of the arm. It's really limited by the whole range of motion of the orientation of the body and even the stepping of the body. And I'm going to say more about that a little bit later. This is a special mode we call chicken head mode. And it's actually a capability that all animals have, which is to stabilize their hand when their body moves. And that means that my brain can think about the task my hand's doing even while the body is moving. And it doesn't have to worry about coordinating the two in an explicit way. Now, one of the things about Spot is it's got a number of onboard computers that are in here and a battery, but it's also got a vision system. And there's cameras right here, 2 sets of stereo cameras there. And go ahead, turn around, Danielle. And there's another set on the side, and another set in the back, a butt cam, and a fourth set over on the other side. So this is a little bit like that teacher who has eyes in the back of her head. Spot is able to see in all directions, and it uses that when it's navigating and also when it does obstacle detection. So I'm going to be an obstacle. Danielle is going to drive it right at me, but when it gets close, it sees me and then treats me as an obstacle and goes around. And Danielle didn't have to do anything to achieve that other than tell it the direction she wanted it to go. And it can also do that with its rear camera. And of course, it can use these cameras in order to navigate obstacles. So here the cameras are used to detect the rock, and it plans its footsteps so that it can step over the rock. And it can do that going forward. Here we'll go over it again once more forward. It can do it going backwards. And it can even do it sideways. So far in this demo, Danielle has been operating the tablet in order to give instructions to the robot, roughly to tell it what to do, even though the robot was doing it itself. Now we're going to do a demo where we switch into a fully autonomous mode. So we're going to start by having Danielle drive the robot around the garage to collect map data. She does that using the onboard LiDAR and the onboard cameras. And then once the data is collected, the robot builds a map. And then we can just tell it to travel in the map as many times as we like. And now the map is already built, and we just tell it to travel along a route within the map that's around the garage. Here's a view that shows you sort of inside the robot's brain as it travels the route, where you can see the path it's on and also some of the point cloud data that's used to guide it as it goes. So that's the end of the live demo. I'm going to continue with the presentation inside. It's a really exciting time in the life of Spot the robot, because we've just made it available as a product and put it on our website as a click-to-buy option last week. For about the last year, we've been working with an early adopter program where we have special customers who we think have either the development skills or problems to solve that fit very well with Spot. And we've been working with those people for about a year, trying out different tasks. So let me show you the kinds of things that we developed, or that our customers developed, in the early adopter program. This is Spot at a British Petroleum facility, and we're using it with a methane sensor to test for leaks. We're using a camera in the hand to read gauges, and the special mobility of Spot is the key feature that makes this robot able to work in these very complex environments. If you think about it, there's facilities like this all over the world, and we hope to be able to use Spot in order to do routine maintenance and inspection operations in all of them. This next shot shows National Grid facility, where there's regions of the facility that humans are not allowed to go in except when the system is shut down, which is only a few times a year. So we're planning to use Spot to go in and make inspections in those areas whenever they need to. This shows Spot being used at a construction site in order to collect data about the progress of construction on a routine basis. Well, this customer started using Spot for a variety of agricultural uses. And this one is the most charming I've seen so far, where Spot is herding sheep along with some border collies that are also in the shot. And we're also starting to test the use of Spot for entertainment. This is a shot that shows Cirque du Soleil interacting with one of their performers, and we're working on making it so Spot can express itself in conjunction with people. A really interesting application for SPOT that just came up recently is using it in the context of COVID-19 and how institutions are going to deal with possible exposure. We've been working with the Brigham and Women's Hospital in Boston and some researchers at MIT to see if we can reduce the amount of contact doctors and nurses make with people who might be infected. And by doing that, save their exposure, but also reduce the use of protective equipment and make the facilities easier to operate. So we've been testing SPOT in a triage center in Boston to interact with patients when they arrive, ask them some questions, get answers, and then decide what the rest of the treatment should be. To do that, we've instrumented the robot with some skins that can be decontaminated, and we've also developed some vital sign testing that really helps out their remote sensing so that neither the robot nor a person has to get close to the patient. We're measuring respiration rate, body temperature, and we're working on oxygenation and heart rate. We don't have those working yet, but we're getting close. So we're really excited by that. But more important maybe than this one application is that this use is making people start to think about robots in a different way. Rather than the first thought be that they're worried about the technology and what bad thing it might do, they're seeing that, that they can be used to keep people out of harm's way, keep them from getting exposed to infected people, keep them out of dangerous situations like that inspection of some of those very complex and old facilities and other things like that. So we've gotten a lot of requests and interest in looking at different ways of using SPOT to protect people. And I think that that's a really exciting view of the future of robots. So that's a little bit about where we are today with the SPOT, the robot. I'm going to talk about the future. The next thing on the future of SPOT is that we're going to make it available with a robot arm in a few months. We have prototypes working, but we don't have them available as a product yet. And once you have an arm on a robot, it becomes a mobile manipulation system. And it really opens up just vast horizons on things robots can do. And I believe that the mobility of the robot will contribute to the dexterity of the robot in ways that we just don't get with current fixed factory automation. So let me show you a couple of things we're working on in mobile manipulation. Well, this is a simple task. SPOT's opening a door. And at least it sounds simple, but I'll tell you, this is such a complicated task for a small robot to do, especially doors like this one that have closers on them to keep them closed when they're not being used. We're also working on the ability to operate devices like this breaker box, which has a complicated load pattern on the hand in order to operate. I had never thought about using the robot to move furniture around, but here SPOT's moving this chair by holding on and dragging it and using its ability to pull in order to maneuver. We also have a project that I'm sure many of you are going to be very interested in, and that's cleaning up your house. Now, SPOT isn't available yet for home use, but someday it will be. And I think you're going to love the idea that the robot could be put in a room and use its vision system to identify your kid's clothing that's been lying around, or maybe your clothing that's been lying around, and then look around and go over it, grasp it, and put it in the laundry basket like this robot is doing in this prototype. Once the engineer said go, there's no interaction. The robot just does all this on its own. It's using a cloud computing to do the vision in order to decide whether the object it's looking at is something that needs to be picked up and sorted, or whether it's something that belongs there and should be left alone. So really excited by this. It's a great example of combining some scholarly intelligence with our mobility and manipulation platform. Here's another possible application for SPOT, and that's delivering packages the last 50 or 100 yards to your home from the delivery truck. I don't know about you, but when I get a package today I worry about whether the driver of the car was adequately careful with washing his hands and wearing his mask and all that stuff. And I don't actually go near him. Wouldn't it be nice if a robot was doing the deliveries so I didn't have that worry? So, as I said at the beginning of this talk, we're really on a journey. And one of the challenges about the journey of making these robots is that people and animals are so good at what they do, they make it look simple. And it's really not. And so we have an incredible amount of work to do if we're going to get robots to be even close to the skills and capabilities of people. We need to make them much easier to program. In fact, you shouldn't be programming them, you should just be telling them what to do. They need to have mechanical systems that are much more reliable, energy efficient. There's just opportunity in every direction in order to get the robots of our dreams. When we achieve the robots of our dreams, they're going to be incredibly useful. We can use them to keep people out of harm's way and to do dangerous work and avoid having people do it. We can use them to take care of the disabled and the elderly. And we can use them in our homes to help us with the many tasks that we have to do every day. I'm really looking forward to that future. I think it's going to take a lot of work by many different kinds of people to do that. I hope you'll work with us to get to some of those goals. Part of the idea of Spot as a platform is that we're not going to do all the development. We're going to work with other people who have their own ideas for what to do. And I hope some of you are those people. I look forward to working with you. Thanks a lot.
Now, if Mark inspired you to try and build on your own love of robots,